I'm sharing with you today a step question that brings together a number of things: completing the square, curve sketching, trigonometric identities and equations, and the theme throughout is really one of maximization and minimization. So this question is from 2019, step 1, and it's quite a long question, but if you follow it systematically and use standard techniques, you'll work your way through it. So we're starting by being told that x is real and theta is a value between 0 and pi. And part 1, we're being asked first of all, by completing the square, to find the minimum value of 9x squared, take 12x cos theta plus 4. So we complete the square as asked, and we get 3x take 2 cos theta squared, take away 4 cos squared theta plus 4. The challenge here is to use the standard technique of completing the square in a slightly difficult situation where there's a cos theta. We have minus 4 cos squared theta add 4, and hopefully we recognise the 1 take cos squared theta and replace that by sine squared theta. So this will take a minimum value when the squared bit is 0. So the minimum value is 4 sine squared theta, and that will take place when 3x equals 2 cos theta, x equals 2 cos theta over 3. 2 points here. The first is, the question says complete the square, so we must do it that way, not by, for example, differentiation. The second thing is, it doesn't actually ask for the x value, although we're going to need it later in the question. Completing the square in various ways is an essential tool for STEP, so it's worth practicing that until you're really fluent. Next part, find also the maximum value of x, as x varies, of 12x squared sine theta take 9x to the 4. It doesn't say to complete the square, so you could use differentiation, but it seems to make sense to use completion of the square again. So doing that, this time we get 4 sine squared theta take 3x squared minus 2 sine theta squared. That will be maximum when the squared bit is 0. So the maximum value is 4 sine squared theta, and that will be when x squared equals 2 sine theta over 3. So just be alert, the minimum value in the first part and the maximum value in the second part are the same. Okay, next part says, hence, that means use what you've just done, determine the values of x and theta that satisfy this equation. It's a quartic equation. Hopefully you spot that it is equivalent to the first expression equaling the second expression. In other words, what we have is 9x squared take 12x cos theta add 4 equals 12x squared sine theta take 9x to the 4. Now we just discovered the left hand side has a minimum value of 4 sine squared theta, and the right hand side has a maximum value of 4 sine squared theta. So the only way they can be equal is when both sides equal 4 sine squared theta, one being maximum and the other being minimum. That's not guaranteed to happen, so we need to find the x value at which that happens if it does. So for the left hand side we need x equals 2 cos theta over 3, and for the right hand side we have x squared equals 2 sine theta over 3. So eliminate x and rearrange. We get a trigonometric equation which we solve using a standard technique. Sine theta equals a half or minus 2. Discard the minus 2 and make sure you note that you've done that. Given the range of theta, Theta must therefore be pi over 6 or 5 pi over 6, and putting that back in we get x is plus or minus 1 over root 3. Make sure you pair up the theta and the x values, make that really clear. And we've done part 1 of the question. Part 2 of the question, we're being asked to sketch a curve y equals x squared over x take theta, where theta is a constant. Once again, theta is between 0 and pi. It's a positive number. So we're going to sketch this. When we sketch curves, we think about things like intercepts, asymptotes, tendencies, turning points. So for this particular curve, put in x as 0, we get y as 0, and y as 0 gives x as 0. There's going to be a vertical asymptote at theta, and there's also going to be an oblique asymptote, that is one which is neither vertical nor horizontal. And the best way of finding this is to do a division to get x plus theta, add theta squared over x take theta. When x gets large, the fractional bit disappears, and we end up with the equation y equals x plus theta, and that is our oblique asymptote. So a line with gradient 1 and cutting the y-axis at theta. So there we have our oblique asymptote. We also have two turning points, a maximum and a minimum, the minimum being at 0, 0, and the maximum being symmetric in the point where the asymptotes intersect. And we're going to find that in just a moment. So there is our graph. We have been asked next to show that x squared over x take theta is either less than or equal to 0 or greater than or equal to 4 theta. So we need the range of y for the graph we've just drawn. In other words, we need to know the turning points. One of them is 0, 0. We need to find the other one. So I would suggest this time we differentiate, probably the alternative divided out version of the curve, dy dx equals 1, take theta squared over x take theta squared, and that will give us y is 0 or 4 theta, x is 0 or 2 theta. So our turning points are 0, 0. That means that y is less than or equal to 0 in the left-hand side of the curve, or y is greater than or equal to 4 theta for the right-hand side of the curve. So we have what it asks, less than or equal to 0, or greater than or equal to 4 theta. Next part. We are asked, maybe by considering the numerator and denominator separately, or otherwise, to show that this inequality is true for all theta values. There are a number of ways of doing this. It doesn't need to be made over complex. The way I've done it is to look at the numerator, sine squared theta cos squared x, and replace both of those parts by their identity. One take cos squared theta, one take sine squared theta. Multiply out, we get 1 add sine squared theta cos squared sine squared x cos squared theta. Take away cos squared theta, add sine squared theta. The bit in brackets is positive, therefore that is less than or equal to 1 plus sine squared x cos squared theta, and divide to get the answer that we've been asked to get. Next part. Hence, determine the values of x and theta that satisfy the equation x squared over 4 theta x take theta equals. Now we've just shown that x squared over x take theta is less than or equal to 0 or greater than or equal to 4 theta. So our left hand side will be less than or equal to 0 or greater than or equal to 1. Which means our right hand side is less than or equal to 0 or greater than or equal to 1. So, writing that down, we have two cases. Case 1, x squared over 4 theta, x take theta is less than or equal to 0. That gives x is 0, and we can discard that. X doesn't equal 0. Or at least it only equals 0 when theta is 0, and we don't want that in this question. The second case we are more interested in, we have x squared over 4 theta, x take theta is larger than or equal to 1, so the right hand side is also greater than or equal to 1. Now we just showed that this expression was less than or equal to 1, so we have the left hand side here being greater than 1 and less than 1 at the same time. There's only one way that can work, which is when the top and the bottom both equal 1. And the only way that's going to work is sine squared of theta is 1 and cos squared of x is 1. So theta is pi over 2 and x is pi. No need to make heavy weather of solving this. It's a relatively straightforward question. Both the top and the bottom must equal 1, and that is a very limited number of solutions. So quite a nice question there. It, as I say, links together completing the square, curve sketching with oblique asymptotes, trigonometric identities, and the connection here between parts 1 and part 2 really is the optimization, the maximization and minimization. When you have two functions equal, one of them has a maximum of 1 and the other has a minimum of 1. The only way they can be equal is where they both equal 1. So quite a good principle there. Nice question. There'll be others like it. This is Gold Standard Maths. I'm David Forster. Join me next week for another step question.